So we've got our first identity right here, our second Pythagorean identity here, and now we have our last one where we divide through by what, you guys? We just did sine, cosine. So now I'm going to divide through by cosine squared x and divide by cosine squared x. So cosine squared x divided by cosine squared x is equal to 1. Sine squared x over cosine squared x is equal to tangent squared x. And 1 over cosine squared is equal to secant squared x. Okay. This is how you get these three, yeah.
We just memorize.
Yeah, don't memorize them. You just divide through, okay? And that's how you get all three. So you always start with cosine squared plus sine squared equals 1, and then you divide through by the cosine, you divide through by the sine, all right? I know. So that's so nice. Okay, now we just manipulate them all. So you may need to write those three out to get you started. I would probably write them all down. And then you want to be like, well, here's some other things I can replace things with now. In other words, I can now say that sine squared theta, now they're using theta, but x is the same thing, sine squared theta. So if I take this one, I can subtract cosine squared x in my head, and that means that sine squared theta is equal to 1 minus cosine squared theta. Write that down. It's on your little paper. The next one says tangent squared theta. So I'm going to look at my third equation there, and I can do this in my head. I can isolate tangent squared by subtracting 1 and subtracting 1. So that would be secant squared theta minus 1. Since they're using thetas, I switched to thetas. Sorry. Okay. And secant squared theta. So that's this one right here. I've already got that one isolated. That's equal to 1 plus tangent squared theta. Do I have to memorize all of these? No. I only have to know those 3 ones. And really, it's just the first one. You just have to know to divide by the cosine squared and the sine squared. All right, now I've got cosine squared theta. So if I'm just looking at cosine squared theta, I want to isolate it in my head. Then, Tyler, what do I get? I want to isolate this guy in my head. Excellent. 1 minus sine squared theta. Okay, cosecant squared theta. So that one's already by itself. So I can say that's equal to cotangent theta plus 1. And then I've got the cotangent. So I've got this guy right here. So Maddie, if I isolate this one, what's it equal to? Yep. Same. All right, we're going to add a couple more just so I know you get this. What if I have cosecant squared x minus cotangent squared x? Okay, what is that equal to? Well, you come up here and you see if those two trig functions are in the same equation, right? And they are. They're in this equation right here. And if I, in my head, subtract this over to the other side, then what's this equal to? 1. Isn't that nice? That's so nice. It's equal to 1. All right. And what if I have tangent squared x minus secant squared x? Okay, so I'm looking at this guy right here. I have tangent squared minus secant squared. Well, in order to do that, I want to keep the tangent squared guy positive, and then I would subtract this, and then I would also have to move this to the other side. Can you do that all in your head? So what do you get? -1. Okay, so you're just manipulating all of those functions. Okay. Let's try some trig. We did change these, so apparently you need to rewrite them. So those of you that worked ahead and already did them, that's great. We have 3 new ones for you. So I know. So just like kind of scratch that one out and write this one down. Apparently these were the same as the book ones, so we had to switch it up. That's like what your homework is. Rude. I know. All right, so first thing you want to notice is that you've got a bunch of stuff squared. If you've got a bunch of stuff squared, you're probably using the Pythagorean identities, which are the ones we just wrote down. And so I would probably, on my paper, literally write down this lovely guy. And I know you already wrote it, so you probably don't need to do it right now. But if you were doing a test or something, I would write that down. Then I would divide through by sine squared, then I would divide through by cosine squared, so I had all three written down, okay? All right, so now I've got cosecant squared x minus cotangent squared x. Is one of those identities, does it already have those two in it? Yes. The second one right here, right? All I need to do is put this over on the other side, subtract it, right? And so what is that equal to, this thing right here? You guys seem hesitant about this. Did you guys understand what's happening right here?
1 plus code.
Okay, you don't have to replace it like that, though. You could. But you guys, literally, I can just subtract this in my head, right? Minus cotangent squared x. So what is cosecant squared x minus cotangent squared x equal to?
1.
It's equal to 1. Thank you. It took you guys a while. All right. Over. Now I've got 1 plus tangent squared x, so I would probably go back and check out my identities. Oh, that's exactly one that I wrote down right here. 1 plus tangent squared x is equal to secant squared x. All right, and 1 over secant squared x is equal to cosine squared x, which is equal to what we're trying to find. Okay. If you want to not rewrite this until you get to the very end, that is fine. So you can just change this side until you get to that part, okay? All right, so I don't have anything squared yet. However, common denominators is always a good thing. But before I start doing common denominators, and how do I know to do common denominators? There's a plus sign and it's a fraction. Anytime there's a fraction and a plus sign, you probably want to find common denominators, okay? So look for that. However, I don't really like cotangents. It's easier to do sines and cosines. So the first thing I'm going to do is change these over to sines and cosines. So 1 over cotangent is the same as tangent. I'll just start with that. And now I'm going to change each of those to sines and cosines. So tangent is equal to what, you guys? Sine over cosine. Cotangent is equal to cosine over sine. Okay, and again, I'm not going to write down this right-hand side until I get to the end. Now I need common denominators. So I'm going to multiply this one by what's missing in this denominator. So this one needs a sine beta over a sine beta. And this one needs a cosine beta over a cosine beta. So always do common denominators when you are adding fractions. Okay, so what do I get? I get sine squared beta now plus cosine squared beta. And I'm going to go ahead and put this all over my common denominator, sine beta cosine beta. I forgot the little squared right there, but that's squared. All right, hopefully this looks like one of your trig identities that you wrote down. So this one right here is your main guy. What's that equal to? That's equal to 1. All right, what I really want to see is that you know how to split this up. So this is the same as 1 over sine beta times 1 over cosine beta. Please show that step, even though I know you can kind of do it in your head. I want to see that you split them into the two functions that you know, okay? So now I have 1 over sine beta, which is equal to cosecant. And I have 1 over cosine beta, which is equal to secant beta. And that's exactly what we're trying to find. So that is equal to what we started with. All right. And the last one. So again, nothing is squared, and you should write this down because it's different than the one that's on your thing. Oh, it's the same? Oh, good. All right. I thought you guys were all just watching. Okay, so I don't have anything squared yet on the left-hand side, but we do need common denominators. Why? Because I'm adding fractions. Anytime you're adding or subtracting fractions, get common denominators. So that means I need to multiply this fraction by what's missing in this fraction. And you actually need to add parentheses. So I'm going to multiply by 1 minus cosine theta over 1 minus cosine theta, because that's what this fraction has that this one doesn't have in the denominator. And then I'm going to multiply by 1 plus cosine theta over 1 plus cosine theta. Sorry, I don't have a little more room. So now this 1 that's right here is going to distribute, and that gives me 1 minus cosine theta. And this 1 over here is going to distribute, so I have plus 1 plus cosine theta. And I'm going to go ahead and put it over my common denominator. I now have a common denominator, right? And you could FOIL this out, and what would happen to your middle terms? They would cancel. These are called conjugates. You guys might want to make note of that. Conjugates are just when you have an opposite in the middle, so your middle terms cancel out. So you get 1 minus cosine squared theta when you FOIL it out. Okay. And this turns out all nice because cosine theta and negative cosine theta cancel. So in the numerator, I now have 2. And in the denominator, I have 1 minus cosine theta. This should look like the first Pythagorean identity, but manipulated around. So it's this one right here. And I would just move this over, 1 minus cosine squared, and so it is equal to sine squared theta. So this guy is equal to this guy based on the number 1 trig identity, sine squared plus cosine squared equals theta. That would be squared right there. All right, and now I can flip this guy. What I'm trying to get is cosecant squared, and since it's in the denominator, I can rewrite it as 2 cosecant squared theta equals 2 cosecant squared theta. Do you guys feel like you can do these? Okay, we'll find out. Let's try a whiteboard problem.